Okay, here we are in my shop where I'm going to be doing some examples of mortar making. We're going to mix up a hot lime mix, similar to what we'd used at Craigdarroch Castle and various other projects across Western Canada. I've heard it referred to as baking a cake or a recipe of some kind, and that's really exactly what it is. We're going to be adding ingredients, mixing them together in certain ratios to create or recreate, if you will, the mortar that was originally in there. This brings us to the testing, which is crucial for designing our mortar mixes. We want to look at what was originally in there and try our best to recreate that. Now, testing is something that's not done much here in Canada, and I think it's important that we, at bare minimum, do a kitchen sink test to understand what the sand looks like that goes into our mortar mixes. So here we got different colors, different textures of sand, from a very coarse, rough sand. These are all relatively fine, and they can get quite coarse, especially for if we're working with stone. The bedding mortar can tend to have larger aggregate in it, moving towards the pointing mortar put on the outside and giving it its beauty. Can be a finer, smoother, soft sand. All our sand generally is going to be sharp, with grains somewhere between 3 to 5 mil is kind of ideal. We can get bigger or smaller depending on what we're using it for. We can sift it down or what have you. Okay, so the next additive we want to talk about, if we're talking about mortars, we're talking about simple mortars, we're talking about mortar color, we can bounce our way into additives like pozzolans. Pozzolanic material gets divided into two categories. You have your natural pozzolanics and you have your artificial or man-made pozzolanics. And basically what a pozzolanic is a clay or silica-based material that's been fired. So our natural pozzolanics are a volcanic stone, like a basalt or something like that, ground up really fine into a powdery dust. By adding a pozzolanic, we're slightly adjusting the way our mortars are setting, and we're giving it that hydraulic set, which allows it to set just a little bit faster and may give it more durability in certain areas. Pozzolanics, here I've got a few examples of pozzolans that we use more often than not. If we're going to use a pozzolanic, it's going to be one of these materials I have here in front of me. The first one is, you might be able to see here how fine this dust is. This gray material right here is called fly ash. It comes from a coal burning blast furnace. It's the ash from that. And adding this to our mortars will give it that hydraulic set. We can get more interesting with that by using something like this, which is a fired pulverized clay brick. So it's basically this brick smashed up and pulverized into a fine dust. And that's going to give us that pozzolanic reaction that we're looking for, that hygroscopic reaction. However, it also will create a very porous aggregate within our mortar, aiding in that ability to suck moisture out of the stones and the walls, keeping that nice, dry, healthy building. And a bonus material is it colors the mortar, and we'll make a beautiful red mortar that matches the brick so precisely. So here's a couple examples of different color brick dusts right here in front of us. Super fine, they'll help give us the color to the mortar. Before we continue with making the mortar, there's a few safety considerations, quick and easy, that I think we should mention. First of all, having an eye wash bottle close by. We are working with high calcium quicklime, which draws its heat from moisture. So we get this in our eyes, it's not a great thing. So here we go, we got an eye wash bottle here. I think it's interesting to point out, here in North America, they say to rinse your eye with water. But in the UK, where they've been working with this for a little bit longer, they suggest sugar water. So what I have here is a bottle of distilled sugar water, which will cancel out the chemical reaction. It will stop that burning sensation and the burrowing into your eye. So this here I always have with me, which is a bottle of sugar water. The other thing to remember, like working with any cementitious material, dust mask. We don't want to inhale this too much. So dust mask, safety glasses, eye wash bottle, doing it in a well-vented room or outside, that's the Gloves are the other thing that are important. If we get lime on our clothing or on our skin, we can simply brush it off. So okay, we're going to make some mortar here. Now, we're going to assume we've gone through our testing, we've looked at our mortar, we understand our ratios and what we're trying to achieve. We've looked at our building, we've looked at our substrate, we understand the condition of our stone, and we understand the location and the requirements that it needs. Is it getting a lot of wind? Is it getting a lot of water? All those things have been taken into consideration. We've come up with a mortar mix ratio. For the sake of this demonstration, we're going to do a simple 3-to-1. Now, that's pretty standard. 3 parts sand to 1 part quicklime. It's a standard ratio. However, it's not necessarily universal. So I've got 3 equal parts sand here. So 1, 2, 3. I've chose to use a fairly smooth, well, it's actually not smooth at all. It's a coarse sand. It's an angular sand. It's just sifted down quite fine. So this would be the kind of sand I would use for a mortar patch, or possibly for some fine pointing or decorative pointing on the outside of our brick or our stone. Okay, we've got our sand in here. Now I'm just going to add our 1 part lime. So that's 3-to-1 right there. That's what it looks like. Now, if I was using a pozzolanic, this would be a great time for me to add that pozzolanic, but for this demonstration, this is what we're going with. A simple 3-to-1. Now I'm going to take that, I'm going to simply knead this together. Like I said, it's like a recipe, like baking a cake. So now I'm going to fold this together. I'm going to blend this up. We can already feel this getting warm. It's taking the moisture that may be in the sand or the atmosphere, and it's starting to slake that lime. The reaction can happen fairly quickly. Now what I'm going to do is I'm just going to fold this together, get it well mixed, and create our roughage here. So I haven't added any water at this point. This is just sand and lime. We're just going to let this sit. I'm going to pile this up nicely. I'm going to let it sit for a bit and do its cooking. Okay, we've got our mortar, or our rough mix here, doing exactly what we want it to do. It's very easy for me to move the trowel through it. And here's where I'm going to add water. Now the key is, I only want to add a little bit of water at a time. I want to add as little water as possible. All I need is the amount of water it takes to slake that lime. I don't need any more. So I'm going to add some water. So I'm just adding a little bit of water as I'm going, mixing by hand with my trowel. Generally, we do this on the scaffold as we're going. We like to use as much mortar at one time that we can. There's no need to make a big batch. Now it's already getting pretty warm. You wouldn't want to grab this with your bare hand. It's about 100 degrees, maybe a little warmer. Depending on the lime, depending on the atmosphere outside and the moisture you have in your sand. Now we'll use up this water in our mortar mix and it'll become quite dry. So it's a little bit of a process. So here we go. So now you can see we're starting to get a bit of the mortar texture you'd think you'd like. Now strangely enough, the best way to make our mortar pliable and workable and soft and sticky and getting that texture that we want in our mortar is by throwing it. And as we throw it, it gets more and more plastic. It gets softer and easier to move. And I can determine the texture I want to work with by throwing my mortar. And as I'm working throughout the day and my mortar starts to stiffen up, I'm not going to add more water to it. and get it soft as we would with a cementitious mortar. We'd add mortar and we'd mix it back up, and we got about an hour to work with it. With this, I have all day. I can work with this all day. I can work with this mortar tomorrow if I don't use it. What I need to do is come back and beat it up, knock up my mortar. Throw it like this. And as you can see, it's getting stickier and stickier and stickier and stickier. And we get this mortar that we want. We're not quite there yet. So I'll keep working my mortar. So this is kind of the consistency I would like for repointing. It's nice and smooth. As you can see, it's pretty darn sticky. Now, we may have noticed we mixed this in a tire rubber trug, right? I didn't use a 5-gallon pail or a standard plastic bucket. And for the simple reason, we melt it. If I was to mix this in a 5-gallon pail, you blow the sides out and it turns into a big mess everywhere. So we mix this either in a steel wheelbarrow or a steel trough. For us on the scaffold, I like to use these trugs. I can pick them up, carry them around, and this is my mortar board and my mixing board. Okay, here we are. We have our mortar made, and we have my little sample test board brick wall here that we're going to do some repointing on. So this wall has been pre-wetted. We've been keeping it fairly moist. But as always, with working with lime or any kind of mortar product, we want that joint to be moist. But here we go. So we're going to take a little bit of our mortar. And like I was pointing out, it's super easy to stack that mortar on our trowel. And we're just going to press it in into our pre-wetted joints. And we're going to pack that in, just like that. I want to press that in fairly hard so we're getting good bond, but I don't need to overwork it. I'm laying it proud. I'm putting it in kind of rough and ready. I'm going to deal with that in a second. So I'll just finish pointing this up and we'll be right back. Okay, I have this filled in, rough and ready. Please don't judge me on my masonry skills from this example alone. We want to build this mortar out, let it sit proud. Now what I'm waiting for is I'm waiting for the case set, or I'm waiting for it to get to what we call leather hard. So as it starts to set, as that carbonation starts to happen, while we're doing that, I'm going to talk a little bit about how we deal with this material in different scenarios. So if we're working on a hot, sunny day, that's pretty much the kiss of death for us. If our material is really hot and dry, that's really tough to work with because our set's going to happen much faster. And in fact, it can happen so quick it'll kill the mortar. We really want to slow that down. And that's really important to keep that substrate damp, not wet, but damp. And if we can keep the sun and the wind off of it, those are the two things that really, really affect how our mortar works. Okay, our mortar is set up now. We have the original case set. We have that leather hard outer surface that we want to start, that we're looking for to start setting this mortar. Now, when I work with this, we want to use a wood tool. We want to go down right to the basic materials here. What I like to use is a piece of wood lath, a wood shim, but ideally what I always carry with me in my handy little pouch right here is one of these wood brushes with a wood handle, and I like to use this to dress my mortar. Now there's a few reasons why I'm doing this, and a few reasons why I'm using a wood tool opposed to a metal tool. If I'm going to use a metal tool, I'm going to get a very different look. So if I use this metal tool and I strike that mortar like you would with a cementitious material, I'm bringing those fines to the surface and I'm sealing off that carbonation process. I'm not allowing the air to move through and carbonate. I'm not allowing that moisture to come out, and I'm not allowing the air to go in and carbonate. So I retarded that process, and the mortar in behind won't set properly, and you get a very weak mortar. So what we do, and what we like to use, is the traditional old school method of using a wood tool. Nothing fancy here. We're literally just striking that mortar off, pressing it into place with a wood tool, and we're dragging it along, and it creates and it opens up the pores of the mortar, and it allows for air to move back and forth. And that's what we want. We want that porosity. We want that ability for that mortar to do its job and to wick the moisture away from our substrate and to bring the salts and the impurities to the surface of that joint and blow away, keeping our substrate healthy. So that's what I'm doing. I'm brushing this or pulling this off with my wood tool. keeping it nice and fancy. The next step is we're going to take a stiff bristle brush. This is a natural bristle brush. Any stiff brush will do. And what we want to do is we don't want to come across and brush the joints like a paintbrush. Because if we do that, we're just sealing up those pores that we opened up. So what we're going to do is we're literally going to beat this back using our beater brush, and we're going to create even more open pores. We're going to assist that carbonation process, and in return, we're going to give it that finished look that we're looking for, that's so often missed in restoration and preservation projects. We miss this point time and time again, or at least that's what we see here. So I'm going to beat this back. Now this is serving a bunch of different purposes here. Not only is it beating the mortar back, opening the pores and allowing carbonation to happen, but I'm also pressing that mortar in. And then we can let that dry. Brush it back. And we've got a finished product. So I'll come back the next day, the next 2 days, following week. I'm going to come back and I'm going to inspect the work that I've done. I'm going to go along, I'm going to look at this and say, oh, I've got an opening. I'm going to come back with my wood tool and I'm going to press it and close it up. Press it and close it up, press it and close it up. Anywhere where I might see an opening, where I might see a fracture starting to happen, or if it's just not sitting tight against the brick or the stone, I come back and open it up and press it into place and beat it back. So there's a little bit more care and maintenance than you'd see in your cementitious mortars. There's a little bit more attention that needs to be paid to it, but it's well worth it in the end. So now I have my wall done, or this section finished. I'm done for the day. I'm ready to go home for the evening and for the weekend. And what I don't want to happen is I don't want the sun to beat down on this. I don't want wind at it to dry it out too quickly, or the sun to cook it. I don't want rain to beat against it and wash away anything that might be there. So what I'm going to do is I'm simply going to cover this wall, or this section of wall. I use burlap. So I got a couple of coffee bags here. We'll buy this in large rolls and cover large works of area, large areas of work, I should say. Simply, I'm just going to do that. I'm going to cover it up. I'm going to hang that off. I'm going to let it sit. I'm going to make sure it doesn't blow away. But that's what I'm going to do. I'm not going to spray it down. I'm not going to wet it. If it was super, super hot and super dry out, I might consider wetting the outside. But I'm not going to soak it straight through. I'm not going to soak that wall like we would if it was an NHL or a cementitious material. I'm not trying to cure it here. It's not something that we need to do with air limes. Of course, air limes being the important word here, I want air to get to it. If I soak this and make it wet and I hang over top, or if I put a piece of plastic over top, we're going to lose that air set. We're going to seal it off, and it's not going to cure as nicely. So what I want to do is I just want to hang this over top, keep the wind from getting at it too strong, keep the sunlight from beating on it, and that's it. Bob's your uncle. That's going to be done. Now I'll let this hang over top of my finished work for at least 7 days. Longer if I can, depending on the atmosphere outside, depending on the weather, depending on what's happening. That's what we're going to do. So being here in Western Canada, winter work is something we need to consider. I'm out here on Victoria on the west coast, so our winters are fairly mild. I generally get away with working most of the winter outside without having to worry too much about covering things up when I'm working in Victoria. However, I work in Alberta and all over the place as well. So, this is something that we need to take into consideration. When working with hotline mortars in the cold, we want to take all the considerations we would with normal masonry work. I generally follow the parameters set forth by modern masonry practices. We generally don't lay mortar in below 5 degrees. However, we can, like I was saying earlier, with air limes, the frost attack in the process when it's setting is much less than it would be in a cementitious mortar, because of course it doesn't start to carbonate until the moisture gets down to 5%. So we're already, very little moisture in that material before it starts to carbonate. So as long as that freezing cycle doesn't hit it when we're putting it in, it should be good. Even if that's the case, it tends to be much more forgiving than a cementitious material. So I'll cover it like this, the same in the winter as I would in the summer. I would protect it much the same. Of course, when we're working in the winter here, sometimes we'll have a heated scaffold and things like that. So as long as you're taking those kind of precautions, working in the winter with this material is not an issue. So what I generally do is, at the base of my scaffold, I put a piece of plywood or whatever I need to keep it clean. And any droppings that happen at the end of the day, I can pick up and put into a pail and reuse the next day. I'm going to demonstrate for you the knocking up process, what we can do with mortar that's past its due date, so to say. This mortar is about a week old. I made this mortar last week, and generally it looks pretty used up. But what I will be able to do is I'll be able to knock this back up and make this a usable mortar again, much like the building does with it when it's laid inside the building and things move and change. That mortar has self-healing properties, and I think this is a great way to demonstrate it. So I'm going to take this old mortar. I'm throwing it in here. Like I said, this was made about a week ago. So it hasn't totally gone off. The carbonation isn't complete. I haven't gotten to a hard, crispy stage. We're not at this stage. These are old. But what I'm going to do is I'm just going to take this, I'm going to put it in this bin, and I'm going to beat it, literally. And as you can see, we're getting back to a workable mortar. Now you can mist this with a little bit of water. We don't want to add too much water because then we'll affect the strength of the mortar. We don't want to do that. So I went from a hard mortar to a soft workable material again. Case study number 1, Craigdarroch Castle, Victoria, British Columbia. The building is located in a coastal environment, which means mild winters with lots of precipitation. The project is a stone rehabilitation project focusing on the replacement of the unsympathetic hard cementitious mortars that are aiding in the deterioration of the local sandstone. We're replacing that with a simple hot lime mortar mix back to the original material. Case study number 2, Memorial Park Library, Calgary, Alberta. Here we're out on the prairie where we have very cold winters and mild summers. I think it's very important to point out too that we have a very active freeze-thaw cycle. We can see freezing in the morning, thawing in the afternoon, and then a quick freeze again that evening, which can be hard on the mortars. This project entailed architectural, sculptural carvings, repointing, as well as plastic mortar repair. This is interesting. We used the hot lime mortar mix to repair the stone, but also draw out the salts from the sandstone that were causing all the damage. We were using the hot lime mortar as a poultice, drawing the salts out as we were applying the hot lime mix, and as it would dry, it would pull the salts out from the stone, where we would have to do the patch a couple of times before the stone was healthy enough to hold the patch. Case study number 3, Medelta Potteries, Medicine Hat, Alberta. Here we have a semi-arid climate that's cold, dry winters, very hot and windy summers, which causes a problem when laying mortar. The project entailed the takedown of a large smokestack and the rebuild of that smokestack using the original brick and, of course, the original mortar mix, which was a hot lime mortar. There was also the takedown and rebuild of a beehive kiln, again using the original historic fabric. The mortar mix in this beehive kiln was a little different because it was a hot lime mortar with clay to create a fire clay for the inner dome of refractory brick.